Good afternoon, everyone, and welcome to the seminar, An Uncertain Elite, Automation and Rationalization of Data Science Work in Germany. We really have a pleasure to have with us today Martin Shedinsky, who has a number of hats. He is a professor of international labor relations at Helmut Schmidt University in Hamburg. He is also the head of the research group Globalization, Work and Protection at WZB Berlin Social Science Center. And he's also the director at Weizenbaum Institute for the Network Society in Berlin. Martin largely focuses his research on technological change in the workplace, and this is an apt place to come and talk to us about his work. In the seminar today, he will address concerns about how automation is reshaping high skilled data work in Germany, and he examines the automation potential in data engineering, data science, and data analytics, fields which are very integral to the development and implementation of AI. For his work, Martin uses semi structured interviews with professionals in German companies, and he reconstructs workflows and explores the interplay between task standardization and organizational dynamics, that is, problem solving, communication, and knowledge evolution, that limit automation feasibility. What he tries underscoring through his study is that while automation enhances efficiency, it does not render high skilled work obsolete. These insights would not only inform debates about employment and evolving roles of data professionals in digital capitalism, but I think what is very important, at least from the ILO's point of view, is also to think about what has been the perception of these data scientists and their role in employee representation within the company, as many of these changes are being brought about through automation. So, without much ado, let me hand over the floor to Martin, who will make a presentation for about 40 to 45 minutes, and then we'll open up the discussion to the floor. So, over to you, Martin. Thank you so much for coming over.
Okay. Thank you very much for inviting me, Uma. Yeah, it's a pleasure being here. Hello to everybody. I hope you hear me well. Today I will report findings, a little bit work in progress from a project we are doing currently on, as Uma mentioned, on automation of data science. Let me briefly share my presentation so that no, this is not this here, this one. I have to wait because actually I am not allowed to share at the moment. So I hope the host gives me these rights. Okay, here I go. Okay, so I will present current research on automation, rationalization of high school work using the example of data engineers, data analysts, data scientists. These are different roles which are often subsumed under the term of data science. This is a work I'm doing with my colleagues Or Josefov, Zeynep Skalidak, who are today not here, who are working with me in this project. Maybe let us start with thinking a little bit about why automation and data science, data analytics, data engineering is particularly interesting for our debates about the future of high skill work. On the one hand, professions in data analytics, data scientists, for instance, are considered a part of tech workers, of the new rising important occupational group which shapes the current digital capitalism. For a long time, we have been reporting increasing employment numbers for data scientists, also for other related occupations like programmers, other IT occupations. This has been a trend for a long time. I remember studies from colleagues who talked about the new aristocrats on the labor market. who described these groups as ascending stars, as let's say the new highly demanded experts. And I think everybody, or most of us at least, have followed media reports in the last month about dismissals, redundancies, about the reduction of demand for these employee groups. So we have actually now a debate if the groups which helped develop the new technologies, new digital technologies like AI, if actually they are digging their own grave. Um, Data science is a profession which is quite important, which is one of the core occupational groups building, working with AI, building AI applications. And some colleagues, in particular James Steinhoff, have argued that actually they will be particularly hit by the development, the progress of AI. I think it's interesting maybe to reflect a little bit on the argument of James Steinhoff. He argued that we have had different waves of automation, that still until a couple of years, we were in a world where automation was mainly based on solutions, on, let's say, deterministic solutions, on solutions which were programmed by humans, but which could only do those things which have been programmed before. And he argues that this is changing now with AI, with machine learning, because now technology is becoming able to learn itself, how he calls it, to create automated solutions. To give an example, so he refers to data scientists to programmers who can create automation bots, who are developing certain code, who are doing certain analysis, and in this way, the technology would automate considerable parts of data science work. In his analysis, this would also completely change labor relations, the relations between capital and workers, um, because while in the former waves of automation, still workers retained a lot of domain knowledge, expertise, which formed the basis for their position in companies, for their demands towards capital. This new developments with AI create a situation where, as he argues, capital is becoming less and less dependent on knowledge of workers. It can increasingly use AI assistants to hire less skilled workers, even in highly complex tasks, like, for instance, data science, because core activities are becoming automated. So I think it's a very good group to discuss current claims about how AI is changing labor market, what the impact is on the relations between workers and capital. And this leads me to the two main questions which will guide my analysis. So the first thing I will look in my presentation is how far automation progressed already in the work processes of data engineers, data scientists, data analysts. I will explain a little bit why I distinguish these groups, these three groups. Actually, when we started this project, we were just talking of data scientists, but we simply saw there are more specialized groups on the labor market with certain differences also regarding what role automation is playing. This is why I distinguish these three. The second is how the characteristics of the work processes of these three groups influence the feasibility of further automation. And after my discussions with Uma when preparing this seminar, at the end, I will also turn to this question of interest representation, of expectations of this employee groups. For this case, actually, I will refer to a second related project which we have been conducting in the German automotive industry. Before I come to our own analysis, maybe a short reflection on what we know in general about, let's say, not from the theoretical perspective, but from empirical studies on the impact of AI on knowledge work. I think from my perspective, the findings are quite contradictory. It's sometimes difficult to get a clear message from research. So we have studies using occupational statistics, which come to quite different estimates. So maybe you've read the recent paper by Frey and Osborne, who reflected on the, let's say, what AI is now changing in the labor market. You might still remember their paper from 2013, where they predicted that digitalization will destroy nearly half of the US jobs in the midterm. So actually, I don't think this came true, and probably 10 years could be like a middle term. So they were not so good with their prediction in 2013, and they are much more cautious now when they discuss, let's say, what AI is changing. I think actually it's quite a relatively interesting paper, which is quite skeptical about the potentials of AI. We have other studies, also from OECD, which use this concept of AI exposure and come to different estimates how many jobs in different occupations have a high AI exposure. The problem with this term of AI exposure is that it tells you relatively little actually about automation feasibility, because AI exposure simply measures how far certain occupations use AI. Um, it does not tell you if this AI is augmenting human work, if it's automating it, substituting it. It's more a concept about the diffusion, which tells us something about the diffusion of AI rather than about its impact on work. We have then a number of experimental studies in labs which examine tasks like programming, writing text, some also creative activities, and test. Usually they test. One group is working with Gen AI tools, others without. Um, Also here, I think the findings are not completely in the line, but we see a certain trend that generative AI might increase productivity of lower skilled, less experienced workers. It's more tricky for more high skilled workers, more experienced workers. There are also some studies which see even detrimental effects of AI usage simply because AI sometimes make errors. And there is an interesting study on experienced programmers who expected to be way faster with AI, but in the experiment were much slower because they had to correct all the errors which the AI tool made. Yeah, but we see certain potential of AI to increase productivity of lower skilled workers, less experienced workers. With the problem here of this experimental studies that that usually they test very clearly designed tasks. Which create the question of how valid they are, because in reality, often the tasks are more complex. You have a lot of collaboration, exchange with other workers. You don't have a very clearly designed task, which you just execute. So there is a question of how far we can transfer the findings of these studies to reality. Then we have these studies examining job announcements after the introduction of ChatGPT. I think this has become quite popular. We see also currently, you might have seen in media, let's say, the decrease of job openings for programmers, for data scientists. So this is surely currently a trend. The problem here is it's hard to say if it's AI, or automation, which is guiding it, because we have also quite difficult economic situation with global trade wars, in Europe also or in Germany, for instance, with stagnating demand for industrial products, with automotive companies and problems. So the question is if this slowdown of job openings reflects particularities of automation or AI-related automation, or rather a more general economic slowdown. And then we have a number of qualitative case studies, which actually are also interesting, but only very few, partially older case studies of, for instance, lawyers, accountants, which come to the conclusion. I think this will resonates a little bit with what I will present, so I want to mention it here, which come to the conclusion that there might be an AI-related automation of certain standard tasks for these occupations, but that the professional core, for instance, in the case of lawyers and accountants, the importance of interactive work in the court or in consulting with clients, that this professional core still remains intact and is not, it cannot be automated. So far about, let's say, empirical studies which we have in the field. There is not so much on data science. There is not so much on data science. Some studies report increasing importance of certain automation tools like AutoML, also the increasing use of coding copilots. But we do not have more extensive studies on what's happening. So let me tell you how we did our own study. So we built on the frameworks developed by colleagues like Debi et al., Sabine Pfeiffer, which you might know. But try to develop, let's say, a more comprehensive framework, which differs also from others, which you might know when we talk about automation. So you might be familiar with the ILO, I'm sure, with the discussion on with the role of the routine or with the routine task intensity index, which is often used to capture the automation feasibility of occupations. This is a usual concept in economics and labor economics. And the routine task intensity index argues that there is one characteristic of tasks which supports automation, and this is standardization. The more standardized certain tasks are, the more feasible is automating these tasks. This argument actually we are sharing. So in our interviews, the extent of standardization of tasks was a very important point. What offsets automation in the, let's say, for instance, in labor economics, in the routine task intensity discussion, usually is two types of non-routine tasks. One are manual tasks. Actually, we don't have this so much in data science. So we did not ask for manual dexterity and non-routine manual tasks in our research. The other type of tasks which is considered as not so easy to automate by labor economists is usually what they call abstract cognitive tasks, which are related to planning, control. And I think this approach, which is still informing many econometric studies, is a little bit outdated with the new developments in AI, because I think we see actually that the new AI tools, new generative AI tools are actually able to take over some of the abstract planning, monitoring, controlling tasks. I think here's a progress. So we, in our discussion, we decided it doesn't bring us forward to ask about the abstract cognitive task, but we have to develop a more differentiated concept. And using work like Sabine Pfeiffer and others, we decided we looked for three dimensions which represent a kind of counterweight to standardization. The first is problem solving. How often are workers, are data scientists confronted with unforeseen problems which they have individually to solve? Yeah, this might be technical problems, the technical infrastructure doesn't work. This might be problems with collaborators, customers, with their superiors, whatever, with the data. You can have a quite standardized work process with all defined steps, but you still can have unforeseen interruptions, problems occurring often or less often in the different steps. So this was something we are looking, consider this first dimension, which would make automation difficult. Yeah, standardization would promote automation. high importance of individual problem solving would be a counterbalance. A second dimension, which would be a counterbalance to standardization, is the communication or collaboration intensity. So how often do data scientists, data analysts have to coordinate their work steps with other actors, to check their tasks, to discuss with customers? This type of communication is not easy to automate, and it brings some unforeseeable elements into the work process. You have to coordinate with other actors, even though you might have a standardized workflow. This limits the possibility to automate all steps. And the third dimension, I'm still struggling if knowledge dynamics is the right term. Maybe it's something like learning intensity. We considered it important to ask how often actually knowledge or how quickly knowledge is becoming outdated. How quickly methods, processes, knowledge might be uh, considered from the scratch. Might how often workers need to learn new things and remodel their own work processes, because also this would limit, in our perspective, automation, because let's say automation in a world where actually knowledge is changing very fast might become very fast outdated. So investments in automation might be worth less if you have such a fast changing world. Yeah. So this is our framework. We asked for standardization and as something which promotes automation, and three types of tasks: problem solving tasks, communication tasks, learning tasks, which form a kind of which represent limits to automation. We asked also in our interviews about, let's say, how much time workers spend on these different tasks. And we looked at all this for all the different steps of the data science work process, which starts often with data collection. Actually, this sounds anyway quite familiar to researchers. I think actually my interest in data science was born maybe just on the margin because it's so similar to research. So I was interested, when will we researchers become automated? And I think it's not like tomorrow. But anyway, so the work process often starts with data collection. It's then about creating data sets, building, maintaining data pipelines, data warehouses, data cleaning, then all these parts of analysis, calculations, data modeling, model building, statistical analysis, up to the visualization, presentation, and writing of reports. Maybe just to visualize this, this was our conceptual model: standardization of tasks, increases feasibility of automation, problem solving, communication, knowledge dynamics or learning, decrease feasibility of automation. What we did was around 50 interviews, 11 expert interviews, and 39 interviews with data scientists, data engineers, data analysts. I will not talk too much about this. You see, it's a quite young population. Most were between 25 and 40. Only among the experts, we had some people of my age, some end 40s at least. Uh, Mainly men, but also some women. A mix of workers from large companies and some from startups. Um, I will not go into details regarding. I will not talk a lot about the differences between these companies. Maybe just let me mention just one thing. In large companies, we had quite specialized roles. So I will describe in a moment these different roles of data engineers, data analysts, data scientists. This clear distinction between the three is something which we find in particular in bigger companies, which have bigger departments. In startups, we often had workers who actually were doing all three roles, or at least a mix of tasks. There was much less specialization. So these roles are something a little bit fluid, which might be more clearly delimited or less, depending on the size of the company, on the form of the work process. And they are Also, some differences which I would maybe like to mention in the background of these three groups, which I will now discuss. When we look at data engineers, they often have a computer science or math background. I think this fits, as you will see, the particularity of this role is this strong focus on data set creation, data pipeline, data warehouses creation and maintenance. This is their core tasks. And as I mentioned, so they had a strong, often background in computer science math. Data scientists actually were really, uh, yeah, had very diverse backgrounds. So we had we they had often PhDs in math, computer science, but also physics. We had some data scientists with PhD in biology, and they all some often also came not directly to work as data scientists, but rather in a later step or second or third step of their career. And finally, the data analysts, and maybe just one, and data scientists, this group has a strong focus on conceptual tasks in model building. This is why this PhD and longer some research, some experience in research is useful in this task. And the third group, data analysts, actually have a strong focus on the exploitation of data, the usage of data, the analysis for practical use cases. Often visualization of data is an important task for this group. We find here workers often with backgrounds in business administration or marketing. So there are some differences which are related to the tasks. Okay, and let me now just go into our findings. So let me start with data engineers, and you see here a table. I will explain it in a moment. I told already, so the core process, the core work process is creating data pipelines. So often they get in touch. Let's say they get a certain request for a department company. They have to check where to get the data for this request, how to convert these data, how to merge data. How to make this data accessible for others by creating a data warehouse, data lake, and maintaining it. So they spend a lot of time on the one hand on communicating with data owners and with those who request the data, and then on creating these data pipelines, data platforms. So they have a quite standardized workflow regarding how to do it. It's called like it's the ETL. ETL workflow. They use standardized or automated tools, but still we see, let's say, a lot of individual problem solving. And let me explain this. So um, we discussed with the data engineers, let's say, um, first of all, the standardization of the task. And let's say the task which were most time consuming were just creating data sets, building, maintaining data pipelines. These tasks were highly, it was a large share of the working time. It was relatively standardized tasks, as I mentioned. So there is a clear protocol how to go ahead, but workers reported extremely high demand for individual problem solving. So fixing problems of data convertibility, of not functioning data, problems with data, uh, a lot of communication demands with customers. So many of the workers we interviewed mentioned that a lot of their work is try also to make sense what their customers want, because they need to create these data to these data warehouses, data pipelines. But often, let's say, those who want to use the data find out only afterwards if the data is really useful and change their demands. So there was a frequent also need to rework these data pipelines, and also relatively strong dynamics in technological dynamics, which mean continuous learning. For us, our interpretation is that actually in this professional core of creating data sets, it, there is we consider the feasibility of automation limited. Despite the standardization, there is a lot of demand of human expertise. Where we see possibilities for automation, these are actually activities which consume relatively little working time, like data collection, but also data cleaning, writing reports. This was not consuming a lot of time. It was not considered something which created a lot of communication, coordination problems or problem solving, highly standardized processes. But as I mentioned, relatively low share in working time of those workers. When we look at the data scientists, we see a similar pattern with a little bit different, let's say, contents. So I mentioned already, the core, professional core of this group is like discovering underlying structures in the data, yeah, to enable forecasts, predictions, which means often like training models, configuring models, building models, in some cases, statistical analysis, and sometimes visualization of data, even though this was a little bit mixed, it consumed less time. And once again, this is the core which really consumes most of the working time of these workers. And when we interviewed them, they said, okay, on the one hand, we have certain standardization of steps, and we have also certain automation tools. I mentioned already AutoML. So they are tools which help with training, configuring machine learning models. Usually, however, this was considered as feasible, usable for some standard applications, but not really the best way for many of the highly specific demands the data scientists had in their companies. So they described a really a high share of the working time really consumed by fixing problems, working on those models, trying new models, looking for problems, for errors, a lot of individual problem solving. Once again, a lot of communication with the departments who demand their services in the company. So once again, this professional core seems to us relatively safe from automation, despite despite the use of automation tools. And where we see more potential for automation, these are the red lines. This is activities which consume actually less working time of data scientists, but also which are for them, yeah, which create less problems, which are usually quite standardized, creating of presentations, data cleaning, also data collection. In their case, data scientists describe data collection, creating data sets as something which does not consume a lot of their time. Our interpretation is that if this is, let's say, a more tricky thing, you will have data engineers, dedicated roles, really working on it, fixing problems. And in cases where data scientists got involved in these tasks, like data collection, creating data sets, this was in situations where access to data, let's say usage of data was less problematic and did not require a specific role. And finally, data analysts. Data analysts, I mentioned this is a group which works actually less in model building and analysis. A core task for this group is visualizing data by means creating dashboards, conducting standard data analysis for management. They focus on practical use cases, business requirements, often use quite standardized platforms like Power BI from Microsoft. Um, Actually, we see this group maybe as most endangered by automation. So also for them, let's say the core, this statistical analysis, visualization, we are quite cautious because once again, in the interviews, the workers describe their own work setting as middle standardized. So there are some standardization steps, but they describe once again high levels of individual problem solving and coordination. Um, so this professional core has limits to how far it can be automated, but we saw some trends to automating task of data collection, creating data sets once again. So as I mentioned, these data analysts often work with standard data, with data which they get within the company without so much problems with quite standardized platforms. And also their reporting tasks, also this part was described by them as something quite standardized, quite automatable, um, and actually something which they expected to be automated soon. So when we look at this, so how did the workers describe how did they perceive themselves automation? And I think one thing we took from our interviews, I think we did not find, or maybe one or two workers only who are really afraid of automation. Actually, what I described, the automation steps um, were considered by them actually as natural. Often they describe themselves as actually it's our job to automate our job. And still, on the other hand, this professional core often remains, this is our perception, intact. So data engineers, so we see like AI tools boost productivity, but we have also this still limited standardization of the profession of tasks in the professional core. Well, how can I go back? Sorry. Um, and they need also a lot of need of coordination with data providers and users. Also, one thing, maybe I think I did not mention it before, there are some advanced platforms which can organize the whole process of creating data pipelines. So you can automate a lot, but also some of the more advanced automation solutions are very costly and still require human oversight. So several companies we talked to said, okay, actually for us, it still makes sense to hire workers because if we use the more costly platforms, we have actually to pay by data volume, uh, and this is getting simply too costly. Data scientists, once again, we see this professional core, which remains intact, which is considered by workers as something also which remains important. Then their knowledge, problem-solving capabilities. Automation supports coding, certain repetitive steps, in particular in building of certain standard models. But interpretation, coordination, validation of results remains human, and it's important. It was stressed by data scientists that it's important to avoid also nonsensical outputs. And finally, data analysis, as I mentioned, so there's a little bit more standardization of tasks in this group. And we see certain threat that these workers might experience, let's say it's a shrinking field of their tasks, in particular due to automation of visualization tasks, reporting tasks. We had some discussion with these workers who are saying, yeah, maybe then also our tasks would move a little bit more towards data management, towards strategic work. They were maybe less secure about their position, but once again, also here, we did not really experience fears of automation in our interviews. What does this all mean? Is there potential for collective organization in this field? I will switch here a little bit. I talked now about a project we are just conducting, and we are working, let's say, on these results of automation and data science. And in parallel, we had a project with an industrial company, which I will report in a moment, where we discussed a little bit more also the question of, is there potential for interest representation? Once again, I think that what we know from research is a little bit mixed. It's a little bit mixed. It's also worth emphasizing that most of studies which discuss this topic have focused on tech companies. There are some studies which actually argue this is a highly individualized field characterized by entrepreneurial orientations, high risk acceptance, so we shouldn't expect a lot of collective organization there. There are other studies you might have, I don't know, maybe you read the interesting papers by Robert Dorschel, who rather found an ethic of mindfulness and openness to collective organization. even though it did not really happen, but he found some openness. This might be also related to the current times, because actually since a few years, it's for the first time that these occupations experience job cuts, that there are certain perceptions of job insecurity, injustice. This might create certain organization. And there are some studies which report on collective organizing by tech workers. And report also the contradictions. On the one hand, these studies argue, okay, this is a group a little bit like engineers who consider, let's say, the individual as the person responsible for its career. Also, they consider themselves as experts who can fight for their own interests. They don't need so much support. On the other hand, they see themselves as producers of a social good for the society. Um, and Rothstein, also Sheehan and Williams, argued that this at least this contradiction led also allowed for the creation of some organizing successes like the Tech Workers Coalition. But this is a very specific American case in the tech community. And our question was how this looks in a European setting, in Germany. So this was a smaller study. We conducted a study in a German automotive company. So we actually, our interest was to compare the perception of engineers, which has been traditionally like a core employee group in the automotive industry. You see it actually, the share and number of engineers is the blue line, and the blue columns have been increasing over time. So I am not talking about this, but this is simply the transformation of the automotive industry from a blue collar to an increasingly white collar industry, with a high share of engineers, nearly 20% in the German automotive industry, even though it's stagnating since 2019. And you see below the IT occupations, actually, we cannot really distinguish data scientists or, let's say, this type of groups in the official statistics, but we can look at IT occupations. They have been increasing. It's now a little bit more than 2% of the employment in the German car industry. The rate of increase is higher than in the case of engineers, but in absolute numbers, still, this is a minority, but an increasingly important minority. And we talked to 23 engineers and 11 tech workers, data scientists and UX, UI designers about their work perceptions. And let me just focus on the outcomes. Actually, this project was, of course, we had to deal with the particularities of the automotive industry, which is something which is often called the twin transition. So we have digitalization, AI, but we have also the electromobility. So actually, this electromobility thing was something quite controversial among the engineers. But I will not discuss all this. I will focus on the green column, on the data scientists. And actually, these data scientists had an interesting ambivalent or ambiguous role, which led us to call them this uncertain elite. Because on the one hand, they had a very high autonomy, work autonomy. They had very good wages. They had very high autonomy in their work, but actually working in an industrial company led them also into a kind of service role, because the products and all the processes in company are still determined by engineers. They are driving the whole process of product and process development. And data scientists were always working in supporting roles and supporting projects for engineering. Their own, let's say, perception of agile work, which they wanted to bring into company, had always to be combined with the way much more rigid industrial product development methods, which also have their reasons why this is much more rigid. But it was also a challenge for data scientists to combine this with their conceptions of good work organization. In difference to engineers, they did not have, or and still do not have, structured career paths in companies. This will surely be different when we would look at American tech companies. But when you look at the German setting, at traditional German companies, data scientists come in are a new group, and they're not yet structured career paths. They have a high status, but there's this self-perception as a lead sometimes does not really correspond to the service role they have for engineers. And we discussed them with about the question if this wouldn't be a reason to engage in works council, to organize, to represent a little bit their interests, to um, but here I have to admit the situation was very similar to what we see in engineering. So works councils, usually data scientists were positive about the works councils. Yeah, they're doing a good job. It's good to have a works council. They take care of us. But when we were talking about their bread and butter interests, they still, as engineers, considered themselves individuals as those responsible for defending, representing their own interests. So I am coming to, I'm approaching the end of my presentation. Yeah. So let me wrap up. Let's say the storyline. I started with this expectation that data science is a profession which seems predestined for automation through AI. Um, and actually, where the employees are really like early adopters of AI applications. Um, but our interviews show that actually this high potential for automation exists only in specific areas, which take only a part of the working time. And despite all the progress, all the standardization of work which exists and which has led to development of many automation applications like AutoML, copilots, certain automation tools such as NIME. This is a tool which allows you to automate the workflow in your data engineering, data science project. Still, let's say core professional roles like, for instance, for data scientists, model building, statistical analysis, they remain still something which requires human expertise, a lot of individual problem solving, extensive coordination with stakeholders, and from our perception, narrow limits to automation. I mentioned the data analysts who work a lot on visualization as a group, which might be hit a little bit more by automation. And I mentioned at the end that this group is, let's say, at least in a context like Germany, where it's a new group which has to integrate often in traditional industrial companies. It's a little bit of a kind of uncertain elite. They have to adapt to rules, to processes, to organizations which have been determined actually by engineers, and they do not yet have clear structured career ways. This is a certain potential for interest representation, but it does not really break the consideration that is very individualized understanding of work. Maybe general conclusions. So I think when we want to understand automation, it would be useful to go beyond, let's say, this routine task intensity discussion, which we have currently, and to look in more detail on factors which limit automation. And our suggestion is that problem solving, coordination, communication, learning might be such aspects. On the labor market, can we expect the demise of data scientists, of new tech workers due to the automation by AI? We don't think so. There is certain potential for rationalization, though. So there might be certain impact on the labor market, but surely not the disappearance of a professional group. Um, Power relations. This is something just to link to what I started with James Steinhoff and his thesis that now AI-based automation is really reshaping labor relations, is shifting power to capital because capital can now get rid of human expertise. We don't see it. I think that still these groups have unique capabilities which result in a strong power position in companies. And I mentioned already the argument of an uncertain elite. Thank you so much. I think I talked now for 45 minutes, so I have been quite in line with what Uma told me. I hope you could follow me, and I'm looking forward for your comments, questions, and maybe also critique suggestions for how to develop this further. Thank you.
Thank you so much, Martin, for this very fascinating presentation and also for sharing the findings from two different fascinating studies into a very nice, coherent picture. And I think what I really liked is you putting meat to the entire thing using interviews and talking to people, understanding even within a sector as to what is happening to this industry and why automation will not lead to displacement of high skilled tech workers, and showing us a complexity that is there. So let me now open the floor, and colleagues, you can raise your hands, and my colleague Pierre Alain will give you the floor. So if you have any questions, either you can put it in the chat or raise your hand, and we'll give the floor. Uh, Quickly, Martin, there was one thing that came up from one of my colleagues, Pavel Gimerek, where I think in your
Hmm.
presentation you choose the 2023 paper. There's an updated paper that has come out. Probably you can refer to that as you get into
I
it.
will. I will. I'm in a revise and resubmit loop
Great.
with the paper, so there is good opportunity to include it.
That's great. And we look forward to looking at the paper. So while I wait for colleagues to ask questions, I have a question to you. You talk about this entire issue of data cleaning and how this could be automated. I want to understand a bit more about the data cleaning within these firms. Is it the data that is very much coming from the company, or is it, as you were saying, because of low standardization of data sources, is it data that is coming from elsewhere? So I want to understand that, because one of the things that we see in our work in the AI supply chains is very clearly the amount of data cleaning, data categorization, and data annotation that goes in, which can be used for modeling per se. So I want you to reflect a bit as to how does it work within the German companies, and whether there are certain safeguards or guardrails that have been put in place that uh, allow you to handle that. While I ask you to answer that, I also have a colleague here in the chat who has a question. His name is William Boschetti. He's a data scientist, he says, and he perceives LLMs making everyday coding tasks much easier. Can the research say something about lowering barriers for data analysts or other workers who are looking to move into more complex and better paid jobs, such as data scientists and data engineers? Could this trend lead to major skills compression in these advanced roles? So if you could take these two, and then we'll come back to other colleagues. Over to you, Martin.
Okay, okay, thank you. So maybe just to start with, sorry, I just noted. Also, data cleaning was your first question. Maybe just to clarify, when I talk about data cleaning, it's not really about, let's say, this data annotation work which you have in
Mm-hmm.
mind, because most workers we discussed with didn't. So they worked, for instance, in industrial companies. So this was sometimes it was customer data, of course, or let's say when it came from marketing, but sometimes this was really like industrial data sources, let's say in chemical companies. And the data cleaning was really a lot about, let's say, eliminating inaccurate data, problems in the data, creating, let's say, assuring a high quality and correctness of the data set, which of course then differed. So let's say when we had, let's say, when we had the data engineers who had to combine data really from different sources, maybe data in different formats, often maybe data which was not well described, data which did not completely correspond to what, let's say the final data users wanted. So those data engineers then spend a lot on this of time on these processes, like getting the data, creating the data pipeline, but also data cleaning. While we had also situations of data analysts, of data scientists who just used existing data for let's say for analysis, and that really did not spend time on this. But this was not so much related to these processes of data annotation. It was, let's say, a more technical task, which in some circumstances created simply still a lot of work. If, let's say, data engineers had to engage with, let's say, difficult to access data sources and data which was maybe had some problems, was corrupted or erroneous in some respects, and they had to clean it. Yeah, so maybe just to say this um, about moving into more complex and better paid jobs. I think this is a good it is a good question. I do not yet have a definite answer to this, because the workers we talked to were really young. They were really young. They often, as I mentioned, like so I think nearly all of them were below 40. Yeah, so most of them were working for 5 to 10 years in these jobs. In these jobs. And I also mentioned that in many, at least in the German context, which we have, at least the companies do not have a structured understanding how these transitions could look like. Yeah. So I think there is, if there is certain uncertainty, then it is about this. How could these transitions look like? Um, this could be, I think, I'm now considering this could be also a good topic actually for a follow up project, just to follow these workers and to look how these transitions work. What I can only say that actually people we talked to were quite optimistic that they can make this transition, even though there was a relatively little support from companies. And even though they did not have a lot of experience in it, their perceptions were really driven by the understanding that their skills are so unique on the labor market, at least on the German one, um, that yeah, they just expected that they would be offered as a certain transition. This might change now with the tightening or the increasingly difficult situation on the labor market. I would suggest I just take the question also with me, or this could be also something we could discuss if the ILO works on it. Um,
Yeah.
yeah, I think it's a good question for a follow-up project.
Yeah, just a quick one to follow on that. I think I would also like to hear you talk about whether this trend would lead to wages or skill compression in these advanced roles. And do you see also same thing within the automobile sector that you spoke to us about?
To
Because this would be something quite of interest to the ILO.
yeah. I have to admit, I
That's
have to
not some.
admit, I do not have wage statistics. So it's for
Mhm.
this group. Um, so I have to admit, I cannot answer it.
Okay,
I cannot answer
that's
it.
fair enough, Martin.
Yeah, we would have
Good.
to look. The problem is we cannot really distinguish these groups within the IT occupations. Um, it might be something one could check maybe or using data from platforms like LinkedIn or others. I would have to think a little bit how to get statistics which might provide information on this. From our qualitative interviews, so 50 interviews, it's a lot for qualitative research, but it's still not enough to make say something about wage compression.
Wage compressions. Okay. I have one more question in the chat, but before that, let me give it to my colleague Pavel Kimmerik. Uh, Pierala, can you give him the mic? Over to you,
Hi.
Pavel.
Hi. I don't think I can switch on my camera, but I can. I hope you can hear
Yeah,
me.
you can speak. Yeah.
Hi, Martin. Thanks.
Hey,
This is a great presentation. I thought you raised a great number of very good points about the complexity of this kind of specialist work and how difficult it is to automate compared to what it might seem from the outside. But these AI tools are also changing. So I'm a little bit curious whether you are also maybe changing your perception, especially about what also my colleague Morgan is asking, these junior posts, which are more and more often discussed, which in ICT jobs in the US, Eric Brynjolfsson and others recently called the canaries in the coal mine. They start observing some effects that they attribute to maybe partially automation in the US, where basically these junior tasks get automated quicker by this technology. And what I mean that these tools are changing is until recently we had to sort of chat with the chat to be able to write code, and it was quite helpful. But by now you can install it inside your data processing folder and software, and it basically knows your data better than you do, and it can do a lot of agentic type of work. It has changed a lot in the last even 3 months. And I wonder about your thoughts around this, whether this changes something, though you raise a really important point that people who work on AI models and machine learning, that experts have to know the basics of their data before they get into complexity and they do something complex with it. And I think it's such a crucial thing, but at the same time, how do you get experts in the future if those junior jobs, if they were maybe passing some of this work to more junior posts, and maybe they don't need to do that now because increasingly these assistants can do this for them. So experts can just do work on their own rather than delegating to juniors. And how would then one become an expert? Yeah, thank you.
Yeah.
Thanks, Pavel. Martin, I'd like to read out from one of my colleagues, Morgan Williams, who's got a question for you, who thanks you for your fascinating presentation. She'd like to learn more about perspectives of young workers within these firms, whether you found that companies are expecting a lower demand for entry level workers, and if this is the case, how will entry level coders gain non coding, interpersonal, and management skills needed to advance their careers? And whether there was any discussion around training programs or other initiatives for them.
Hmm. I think this is like
Yeah,
Pavel's
I think Pavel
question.
picked up on what
Yeah, exactly.
Morgan was
Yeah,
saying too. So, but I
yeah.
thought it's good to give her the credit.
Yeah. Just by curiosity, is it Pavel or Pavel?
Yeah,
It's
it's Pavel,
Pavel.
it's a Polish name. Yeah, that's
Wspaniale, wspaniale. Okay, so I have to admit, I I'm a little bit skeptical. Simply, I wonder how we can know if so. I think when we have an economic slowdown and firms stop hiring, it will always hit the job entrance. So because like the senior people are already in employment, so um, still a little bit cautious about really saying this is automation and AI related because we have so many factors impacting the labor market at the moment. Yeah, so I'm not. I'm simply not not convinced. And when I talk to company people, but this is more like an anecdotal evidence because so when we talk to managers and companies, my understanding is still that they are aware of the problem. Yeah, just to give an example, we are currently doing we are currently doing a study with a German software company. Actually, the management wants the workers to use AI, and the workers are saying, "Oh no, it doesn't really help." So the management is doing classes with them and trying to support them in using an AI. Um, but at the same time, so yeah, and for us it's interesting. We want to follow, let's say, this company like for 1 or 2 years and see how really the work processes. In this case, it's not data science, it's programmers, how the work processes really change. But what's interesting that even though they are doing it, they still have their vocational education training, where they are still, let's say, training Fachinformatiker, and they have a dual Studiengang also for computer science, and they are continuing this. And they also, we discussed also with the with the trainee, and he said, yeah, So actually, I'm trying not to use AI because still I want to learn, let's say, the basic by myself and to understand them before I start using AI. Of course, this is
Mhm.
a single case, yeah, and it tells that cannot tell us anything about the general dynamics. What I just want to say, I hear from companies also different things. Some I see, I sometimes I hear about exactly what you're saying about, yeah, we might need less, let's say, junior roles. I sometimes I'm in companies where they are still investing in training. I still hesitate saying like, because we see these trends and job vacancies, or in let's say the reduction also of job openings, we see that junior roles are suffering more. This is already AI, because I think this is this is something we will observe in any situation of a slowing down labor market, that those people who are new on the labor market will be dismissed first, or will have particular difficulties of finding a first job. So, well, I don't know if I'm convincing. I still, yeah, a little bit cautious.
Mhm. Martin, a question that I have while we wait for anybody else who wants to ask. How easy or difficult it was for you to conduct these interviews? Are the companies quite open to actually discuss about many of these issues that you are raising on automation, or is there, or is it really difficult to get hold of different levels of workers to discuss about it? Because in our own work where we do case study approaches, we do find it difficult. So I wanted to hear a bit more. Or is it something that the industry is interested in, asked you to come in and try to do an analysis?
Mm. So, let's say in this case, let's say in the first project, we recruited the interviewees individually. So it was not via their companies.
Mm-hmm.
We recruited them individually. So, but in other studies, like let's say the second one, which I mentioned with the automotive company, this wasn't such a problem. My feeling is that, let's say, at least in the German context in which we often do our case studies, um, it's still maybe the demand for those skills is still so high that companies are rather interested in the question, let's say, on the one hand, in the question, let's say, how does the work process look like? How is the work organization? Which skills are needed? How could we create career ways? Let's say for these, at least these are questions. So they are, for instance, there are not so many structured career ways, but we found, let's say, for this occupational group, which are not the exploited, let's say, logistics workers of Amazon, but rather, let's say, a relatively highly paid and high status group. This was something which companies are quite interested to discuss. Also, also we see also another type of questions now coming from companies. Um,
Mm-hmm.
let's say there is, I think many companies and also many, let's say, managers are also themselves quite insecure how far the new types of AI assistants, be it in coding, but you have also these AI assistants in accounting. You can use it in marketing, in many functions. What really the time gains are. Um, because it's not always very clear to companies. We have also these studies, probably you heard also about it, the last
Mm-hmm.
Bauer study in Germany, the
Yeah.
survey, which showed actually
Mm-hmm.
that many people are using chatbots individually and informally, even though the company did not introduce it. And my experience is that many managers are quite insecure. So, uh, does it bring anything? So, does it mean I should press my people more or increase the performance demands? Like Pavo mentioned, yeah. So we have this agentic tools now, which could save us a lot of time. Does it mean I can ask my department to deliver 30% more
Mm-hmm.
or not? How do we cope with risks? We had also discussions in, for instance, in one purchasing department in a company. So this was a project about, actually they introduced an AI assistant chatbot in different functions, and we followed this. And they said, okay, we have then to deal, because it makes mistakes, so we have to develop strategies how to cope with these risks, what we can tolerate. So if it's something, let's say, if it's something we are buying up to 5,000 euro, we don't mind, so we don't check what the AI bot is suggesting to us. If it's more, it still has to go through a human worker, so then the time gains a little bit are more limited. Yeah, so I think there is a lot of insecurity, and we see relatively high openness also of companies to discuss this. Much more than maybe if we asked, okay, about blue collar, let's say blue collars.
Yeah, so it's largely because it's white collar jobs. It's an easy entry point here. There's one more question that I do want to follow up, which is of quite a bit of interest for us at the ILO, based on the work we have been also doing. What I see from your work, both on the automobile sector and the other one, is there's a lot of initiatives within the companies to develop technologies using some of the existing AI tools and all of that, depending upon the needs of the company per se. So there's not so much of off-the-shelf technology that is being used. Would I be correct in my understanding, or you see a sort of a mix of the two that companies are using?
Uh, I think it's a mix. This will depend a lot on the task and the occupation and also the price. So I mentioned already in some cases, for this was the particular pronounced in this and data engineering field, where some, so let's say, data engineers working in smaller companies said, yeah, we have, so using the, let's say, the top tools which can help us automate a lot would be very expensive. So we rather do it still. We build, let's say, the extractors, data extractors ourselves. It's simply cheaper for us. And we see this also in different fields. For instance, we are the I'm switching a little bit to the feed from data science to other, but maybe this is also interesting. Um, in this company where we followed the introduction of this AI assistance chatbot in these different, let's say, high skill white collar groups, they first tried to use the Microsoft solution, which worked okay, but they simply came to the conclusion that the gains are simply not worth the price. Which for me, so it doesn't mean there are no gains. It doesn't mean there are no gains, but it gives also a little bit a realistic also picture. Yeah, so paying for the actually, yeah, paying for like Microsoft Office chatbot Copilot was too expensive for them, so it was not worth the gains. But they are now investing like in building an own in own company owned chatbot based on open source solutions, which is cheaper, which then is maybe let's say offers less option. They have to they can customize it more. Yeah, so there are different considerations, sometimes price, what fits, what is useful, which gains companies have. I think it's difficult to have like a uniform answer for different types of companies and jobs.
Thank you so much, Martin. And if there are no more questions from our colleagues, I think we can now close the seminar. Thank you once again for this very fascinating presentation and very valuable insights that you have given us through your work. And we look forward to reading your final paper, but we'll continue this discussion and looking forward to more collaboration with you on the work we are doing in this area. Thanks a lot, Martin.
I have to thank. Yeah, it was a real pleasure. I'm looking forward to read the 25 update. 25 update. Yeah, and really hope to continue collaboration. This will, yeah, would be
Thanks a lot.
wonderful. Thank you so
Yeah.
much.
Thank you so much. Bye, Martin.
Bye.